Another type of problem that we'll see that systems can help us are simple interest problems. And we might remember that interest is equal to its principal times its rate. So let's look at this idea that I have here. I got my grandma, and she wants to invest or can invest $50,000 into a couple of different types of funds. One fund will yield her 15%, and the other one she has to put in will be at 7%. And she's hoping that after the year is over, she'll make $6,000, is what she needs to kind of make this work. So, given the starting information and our emerging understanding of systems, let's see what we can do. Well, first of all, is I don't know how much money she's investing at this rate or that rate. So one thing we always try to do is write a variable or create a variable. And this is the amount of money at 15%. And the other amount is the amount of money at 7%. Okay, $50,000 total. X amount plus Y amount equals 50,000. That's the starting spot. Don't know? Don't know, but we know them both of those amounts combined equals 50,000. It can be 30,000 and 20,000, 10 and 40, 5 and 45. Remember, systems produce unlimited, or equations can produce unlimited solutions or unlimited coordinate pairs. Systems will produce an intersection, will produce a unique solution most of the time. So that's one that we know. We know that she wants to make $6,000 if she invests the right amount. So 0.15 x plus the other one is 0.07 y. So if she invests the x amount at 15%, adds it to the y amount at 7%, she's hoping to make $6,000. So those are two systems or two equations that I was able to develop. And once I was able to do that, I created a system. Two unknowns. How much is she investing in one account? How much is she investing in the other account? And then the investment off of both those accounts, what do they equal? So there's my system. Now from there, it's working it through. Maybe what I would choose to do, I might do a couple different things here. I don't know. I'm going to multiply the first one by the second one by 100. For me, I'm not a fan of decimals and fractions. If I can eliminate them as soon as possible, that's a good thing. So let's rewrite the system. X plus Y equals 50,000. Multiply the second one through, gives me a 15x plus 7y equals 600,000. Now, all of a sudden, her money just didn't go from 6,000 to 600,000. All we did is just manipulated through our algebra the equation to come up with an equivalent equation. Okay, there's my second iteration of the system. Let's multiply the top one by a -7. So I have -7x minus 7y equals minus 350,000. Did I do that correctly? The second one stays the same, 15x plus 7y equals 600,000. There's my third iteration of the system. Now I'm able to eliminate a term. So I have 8x equals 250,000. And so x will now equal, I got to do some math over here, folks. 8 goes in there 3 times, 24. 1 and 0 goes in there 1, 8, 2 and 0 goes in there twice, gives me 16. A 4 and a 0 goes in there 5 and a 0. So x equals $31,250. So she's going to invest $31,250 of her $50,000 at the 15% yield, because we said the X is at the 15% yield. And how much is the Y? Well, I'm going to look for any equation, and this one looks like the easiest one to me. 31,250 plus Y equals 50,000. Subtract that, I get Y equals, what is it, 18,750? Yep. So her second amount at 7% is 18,750. And those are the two amounts that she divided on up. It's exactly those two amounts that will yield her $6,000 after the first year. Boy, kind of got to get to know my grandma a little bit better, don't I?